Okay, so to solve problems that have square roots in them, we want to think about squaring to cancel the square root. When we square both sides, our equation remains true. And the right side is very easy to square. That's going to turn into 3. On this side, however, we want to be really careful. When I square this, I'm squaring the whole quantity, not individual terms. So this is going to turn into root of n plus 9 squared minus 2 root n times root n plus 9 plus root n squared. So we're expanding a binomial here. So that's why we're following our rules for binomial expansion. So minus 2. So now this is going to turn into n plus 9 minus 2 root n times n plus 9 plus n equals 3. I'm going to move everything that's not radical to the opposite side. So negative 2 root n plus 9 equals, let's see, n plus n would be 2n, subtract it to the other side is negative 2n. 9 minus 2 is 7, subtract it to the other side, and I would get negative 4. Okay, I can divide everything by negative 2 to get root n times n plus 9 is equal to n plus 2, dividing by the negative 2. And now I'm going to square both sides again. And that's going to give me, coming up here, now when I square, I have just one square root to cancel. N times n plus 9 equals n squared plus 4n plus 4. Again, expanding a binomial. So now n squared plus 9n, n squared plus 4n plus 4. That's a 9n, sorry. When I subtract, those are going to cancel. I'm going to end up with negative 5n plus 4 equals 0. N is 4/5. And then I want to come back and test this in my equation, make sure that I haven't ended up squaring any negatives, square rooting any negatives, which I haven't. So this is a valid solution. All right. This one is much easier to solve. So I'm going to make some space over here because I can move my 3k to the opposite side. So 4 root k is equal to 2 minus 3k. Again, I'll square both sides. So squaring the whole quantity is going to give me 16k. Squaring the whole quantity is going to give me 4 minus 12k plus 9k squared. Again, expanding the binomial. And now when I collect all my like terms, I'm going to have 9k squared minus 28k plus 4 equals 0. So let's think if I can end up with 28 in any way. I don't think that I can, so I'm going to use quadratic formula. K is equal to 28 over 18 plus or minus square root. I have no idea what that's going to turn into. Let's come into my calculator. So 28 squared minus 4 times 9 times 4, 640 over 18. Now, if this had factored, 640 would be a perfect square. Let's see if it is. All right, so I was correct in thinking that it didn't factor. I can simplify this down. I want to make sure that I'm not going to take the square root of any negative. So what I really care about is if 28 minus the square root of 640 is going to be a negative number, and it's not. So that tells me that both of my answers are valid answers in here. And I can simplify it or I can leave it like this.